In our last session, we considered two masses that are the same colliding elastically. And we discovered that the kinetic energy that was lost during the collision was 50%. But then it came back. It was stored as spring potential, but it came back to pure elastic again. But it was 50% of the total amount of energy. Now we want to consider what happens when a heavy cart hits a light cart. Now this would be better to demonstrate, and I will do that in class. But for now, just kind of going over the basic idea. So you have a heavy cart hitting a light cart. You can imagine that when heavy hits light, it doesn't change its velocity very much during the collision. In other words, a big object hitting a small one. That big object keeps moving at just about the same rate. And because kinetic energy is 1/2 mv squared, the kinetic energy is highly dependent on the velocity, or I'll just say speed in this case. So let's consider then the hint I was giving you. What happens to the total kinetic energy? What happens to the kinetic energy during the collision in particular? So it starts out, as we can see here, all the energy is kinetic. During the collision, because its speed doesn't change very much, you will probably not be too surprised that the kinetic energy doesn't dip down so much. So it's just going to drop a little bit. Now I'm not going to quantify this because that takes a lot more effort and I don't want to spend the time on it. But based on what the masses are, we can actually compute exactly how much kinetic energy loss there is, or internal energy stored. But again, the kinetic energy total before is equal to after. We get it back. So we have this internal energy here. Just like before, we have internal energy. It's spring potential. So during the collision, the motion of the big cart, the massive cart, has not changed appreciably. So both carts are moving then, even during this collision point, even at the midpoint of the collision. There's been a reduction in velocity, yes, or speed. There's been a reduction, but it's not that much. Total momentum is conserved, which means the total mass of the two carts times the speed here, the speed represented by this point, is the same as the mass of the heavy cart times the speed initially. And again, it just doesn't change very much. So we don't lose very much kinetic energy. They're both moving at a relatively high rate of speed right through the collision. The big cart never slows down very much. All right. So the midpoint kinetic energy is greater than 50%. So that's all I'm going to ask you to know here. It's going to be more than 50% of the total energy. And now let's look at the opposite extreme. So we have a light cart hitting a heavy cart. Well, the opposite considerations will now hold. So here's the 50% mark. We start with the kinetic energy total. But if you have a light object hitting a heavy, and if you consider during the collision, at the midpoint of the collision, that poor little light object has deformed a little bit. In this case, the plunger goes in. But that heavy object sitting there with all of its inertia, the massive inertia, it says, I don't want to move. And it doesn't move very much in the first half of the collision. It just moves a little bit. So its motion, its speed at the end of the first half of the collision is quite small. And that's the speed of the small object. So the small object, guess what? How much of its kinetic energy has been lost? That's right, most of it. So, in this case, it's going to dip way down. Then we get it back again. So how far down it dips, again, depends on the particular ratio of masses. But the smaller the mass of the light cart that's colliding elastically, the deeper this will dip down. So here's that internal energy in spring potential once again. So, some words to clarify all this. The massive cart is like a brick wall. It's this massive, immovable object, almost, not quite. So the speed becomes very close to zero at this point in the collision right here. And then, however, if you think about it, the big object, the massive cart, is not going to ever be moving very fast. The spring plunger is going to actually accelerate or launch the light cart backwards in the second half of the collision. So we have almost all the kinetic energy lost during the collision. So I'm talking about here. Kinetic energy is just wee little bit. Look at that little bitty kinetic energy. But then we get it back after the spring plunges it back once again. So that's a quick overview of different mass ratios and how they function in an elastic collision.